Morning, everyone. So today let's work on another LeetCode quiz. So let's choose a medium level of difficulty. Okay, this one's a good one. Let's work on this one. So the question is minimum operations to make the integer 0. You are given two integers, num1 and num2. In one operation, you can choose integer I in the range 0 to 60 and subtract 2 to the power I plus num2 from num1. Return the integer denoting the minimum number of operations needed to make num1 equal to 0. If it is impossible to make num1 equal to 0, return -1. Okay, we get two examples here. The first example, input num1 is 3, num2 is -2. We can make 3 equal to 0 with the following operations. We choose I is equal to 2. And subtract 2 to the power of 2 plus -2 from 3. 3 is equal to 1. Then we choose I is equal to 2 and subtract from 1. Then we choose I is equal to 0 and subtract from -1. Then we get 0. It can be proven that 3 is the minimum number of operations that we need to perform. Example 2. Num1 is 5, num2 is 7. It can be proven that it is impossible to make 5 equal to 0 with the given operation. Okay. So again, I think that let's start with a test case. Let's get input. Num1 is to 3. Num2 is to -2. Okay. So step 0. Let's say step 1. Of course, we always start by some check some, edge case first. So let's say check whether num2 is 0 or not, right? And then what we need to do? In this case, let's make t is 1. Then the target will be num1 minus num2 multiplied by t, right? Because how many operations we do we will subtract t for t times, right? So in this case, it would be just 3 minus 2. So it will be 5, right? Then five, and then we need to check whether 5 can be, the power of 2, right? Can be, can be, the power of 2. How do you say that?
Power.
Okay, can be powers of 2. It's interesting. Me means power. Does that mean that exponential is power? Well, anyway. So what do we need to do? So we need to perp count target. In this case is 5, right? And 2. Because from binary perspective, we are 101. Make sense? Then we need to try t is equal to 2, right? And now our target will be 3 subtract minus 4, it will be 7. Make sense? Then hop count 7 will be 3. And will be binary 111. Still not match. Right? And then step 4, it is 3. Then our target will be 3 minus 3 subtract minus 6, and will be 9. And pop count 9 will be what? Will be 2. Because binary is 1001. Make sense? Right? And 3 smaller than 3. So minimum is t is equal to 3. Right? Because imagine here we can control, right? Control which I we want to get. So we need 3, num 2. And we only need 2 power of I. Then it works. So based on this, specific case, let's try to generalize it. So the input will be two parameters. First one is int, second one is int, return type is int. Okay. So again, let's to check if num1 is already 0, right? So if num1 already 0, then what do? We just return 0. Super straightforward, right? Then what we need to do? We will search for the minimum number of operations t. Make sense? We will search for the minimum number of operations t. Okay? And since the problem limits I to 0 to 6t. So we can make t in range of, let's say, 1 to 100. Make sense? Right? And our target is to find t. And if target is negative, what should we do? If target is smaller than 0, then we need to keep going, right? Because we didn't find, our goal. And if target is less than t, what should we do? Again, we need to keep going because we don't have enough total to allocate t positive powers of 2, right? And then we need to count how many 1 in the target, right? So we need to count number of 1 characters in the target. Here we use a function bin to do that. So this is to convert our integer into binary. And then we need to count how many 1 here. So we can use count to calculate how many 1 here, right? So if the number of side bits is smaller than t, what does that mean? It means that we found the minimum t, right? That satisfies the constraints. So if the number set bits smaller than t, so then we just return t, right? But if we cannot, then we just return -1 because we just find nothing. Make sense? So I think that the key idea here is to compile the number of t, the number of one and the target, right? Let's try it. Okay. One counts. Okay, one's count. And the trick here is that we use two operations. One is, change integer to category. So another one is to count the number of one. Okay, so the time complexity is O1. Okay, looks good. Okay, space complexity is also O1. Well. It's already O1, but there are still some, some code. Use smaller memory or smaller runtime. Okay, interesting. Okay, so again, I think that we need to know several things. The first thing is that explains the building functions, methods, operations, and step by step visualized test case in the worst case. Yeah, so I think that when we say algorithm, what we are talking about is to find a solution that can be generalized to different situations, right? When we use one specific test case and try to understand how we find the solutions from specific test case, we are trying to find a way to generalize. If you can find a way to generalize, then you will find the algorithm. The other thing is just about how to write the code, right? No matter you write in Python, C++, Java, it's just about difference about syntax. But the core is the steps how to tackle this issue, right? And also from another perspective, when we explain the algorithm to, let's say, an interview, what matters most may not, just start writing code. It's not what they're looking for. They doesn't look for a code. Look for how you think about this question. How what's your algorithm? What's your generalized approach? Okay. Okay, so here are some built-ins. Range 1 to 101 creates an iterator of integers from 1 to 100. Inclusive of 1, exclusive of 101. For t in range, standard counting loop over those integers. Target is equal to num1, subtract t multiple and num2. Subtraction, okay? And multiplication. Comparison, if target is continue, skip the rest of the current loop body, go to the next t. Return to your return -1. Immediately exit the function with this value. Battery target. Return a string like OB 101001 representing the target. In base 2, prefix is 0-bit. Some string .count1 counts occurrences of character 1 in the string. Here counts side bits. Note, counting 1 also counts the 1 of the OB prefix. That's fine, because prefix has no 1. Comment. Indentation. Python's block structure is defined by consistent indentation. Spaces recommended. Okay, so here is an example. Okay, so for example, input is num1 is 3, num2 is -1. When t is equal to 1, then target is 5, right? And the battery of target will be 101. So here there are 2, 1, right? 5 smaller than 0? No. 5 smaller than 1? No. 2 smaller than 1? No. Then continue. 7 smaller than 0? No. 7 smaller than 2? No. 3 smaller than 2? No. Continue. T is equal to 3. 9 smaller than 0? No. 9 smaller than 3? No. Two smaller than 3? Yes. Then return 3. And we can do a intuition check. When t is 3, after subtracting -2 3 times, we efficiently added 6. That will make 3 become 9. 9 is only 2 power of 2, which is 8 plus 1, which fits within 3 splits. But what I but the thing that every time okay. But actually, what you subtract is not 3 and 1, but 4, 4, 1. Okay. Four, four, one. Okay. 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 Yeah. So I think that's pretty much for this question. And yeah. And again, so several key tricks. The first one is that we need to have a generalized methods, right? The key is to ensure that the target, the count of one, is smaller than t. The second trick is that utilize binary function to convert the integer into a binary string. Use count to count numbers of one in the string. Yeah, I think that's pretty much for this question. Thank you, everyone. Bye.